Hello, everyone. Welcome to the horrifying image of an infinity screen on my copy of OBS Studio. Or maybe it's just OBS. I think S is Studio. Uh, I haven't yet mastered switching over, so this is an unpleasant start. But what we're doing here is a demo of Amazon EKS. I'll switch over to VS Code here. It'd be nicer to look at. We are going to be looking at auto mode, which is somewhere in between Fargate, which is mostly serverless, completely managed kind of service, and running your own managed nodes with maybe add-ons to manage things like, I'm saying manage a lot, to control things such as core DNS, CNI plugins, that sort of thing. I have already spun up a cluster because the repo I have associated with this demo, it's going to take a moment to spin everything up. Give it 10, 15, 20 minutes. It could be a bit lengthy. So I did it ahead of time. We'll be looking through the GitHub repo here real quick. I'll include a link to it in the description for the video, and then we'll go take a look at the console and kind of go over what it created and that sort of thing as well. And then we'll take a look at the cluster. We can go over its specific, the specific fun there. That'll distinguish it between, running managed worker nodes and using Kubernetes add-ons, which is pretty hands-off. I mean, that's about as hands-off as the non-managed version gets. To start with, we have a series of configuration files. This is a standard cluster config used for the EKS control tool. You don't have to use, you have other options to deploy auto mode. If there's any interest in other ways to deploy EKS, other tooling, feel free to comment, reach out, and I'd be happy to do tutorials along those lines. The only thing we'll show here that you will notice is it does have this auto mode config key. Leads to a map, and that's set to enabled. That allows you the cluster to start with auto mode. You can also convert a cluster to auto mode. Again, I could do a tutorial on that if there's any interest. Not something I've done yet, so I wouldn't mind getting my hands on it. And then I've set there to be you can set the default node pools. This is a Carpenter concept. Carpenter is an auto scaler that scales worker nodes for you on the cluster. It works with more than just AWS, but AWS they were the ones that created it initially. So it's kind of built with that in mind. You provide it with I'll go over it. We have two of these to go over. You describe node classes and node pools, and it creates an object called a node claim, which allows it to bring up and drop nodes in EC2 instances in this case. And it can use spot or on demand because it's not using the cluster autoscaler, which is the standard scaling mechanism on these, works with auto scaling groups in AWS. And these are a little slow compared to what Kubernetes needs sometimes. There's a bit of a life cycle for all the nodes. Useful for predictable scaling, but not so useful for spikes and sudden surges. Kind of a known problem with ASG in general and the ilk. So one way to get around this was simply to bring up nodes as fast as possible and join them, but not manage them as a scaling group. Caveat there, of course, caveat emptor. The caveat there is that by running these autoscalers on your cluster, they can become disabled. They can become damaged in some way or even be evicted if you're not careful. You can work around that to make sure they're not evicted. And then your scaling sort of goes away. You kind of in a infinite loop, sort of. You have no way of dealing with the pressure, and the pressure mounts, and you have no way of dealing with it. It mounts further, and so on. We will go over that in a second. There's a useful feature here for that as well. But Carpenter is much better at expanding and contracting under high load than the cluster autoscaler is generally. You can run both as well, just for the record. Again, a tutorial I'd be willing to go over if anyone's interested. So when you use auto mode, you're going to be using Carpenter as your auto scaling. There are not going to be ASGs involved here. I don't know of a way to configure them. You might be able to run the cluster auto scaler on the cluster. I'm not going to do that here. There may be a way to do it. I don't think you should, because I think that methodology is a little old-fashioned for Kubernetes native. But yeah, you may have good reasons again to run both. Now I am passing in a custom node class here. You don't have to do this. There's a default node class and a default node pool that will become implemented. There's a couple node pools you can activate. One is called system, I think, and one is default, or I can't remember what the other one's called. It defaults to spawning a number of decent size, one or more of a number of decent sized C type, M type, maybe I can't remember what it defaults S type. There's a couple different instance types. It defaults to in the maybe small through large range by default. I don't want it to do that here for my testing, so I implemented a custom node class, and that was only so I could implement a custom node pool. Because if you're going to go custom on this, these are again Carpenter native objects, but AWS did implement their own API that sort of adjusts the general Carpenter system just slightly, and that's because Carpenter is currently, again, built in such a way that you could technically use it for other platforms, but it was originally designed by AWS, so they have their own version of it here that works more natively. This is an IAM role, which we'll look at in a moment, being created as part of this. And these are tags pointing to the subnet and security group. You can get more fancy with this. This is just an easy way for me to point to that network infrastructure. Basically, a node class defines a template for what type of infrastructure you're deploying, and node pool sets the exacts of how you're deploying it. You can think of it that way. Node class is what you're going to deploy, and node pool is how you're going to deploy it. If we look over at the node pool here, we can see that the S code is being ugly. We can see that it defines the node class reference. We call this thing default. And then here are some requirements that allows Carpenter to kind of validate configs for potential instances that can satisfy resource requirements. Kind of a validation step. For example, here I'm telling it that the only instance type I want it to spawn are T2 mediums. That's for price purposes, and also because of the service I'm using to show this. They don't want, like anyone, they don't want you to spawn a bunch of big instances, which is fair. So I'm keeping them small. And then this is just the zone that you can spawn them in. You can limit which nodes it's spawning into, and so on and so forth. I'm letting it touch any of the availability zones in the US West 2 region. And that's it. This was, again, just to prevent it from spinning up, more pricey instances. If you don't do this, you don't have to do any of this customization of Carpenter. This is purely my choice. It's one of the few customization steps you can take with auto mode. Auto mode disables a lot of customization. I'll end the talk with a sense of where I think you should use this, but again, it's going to be kind of my usual advice on how to go from managed / serverless technologies all the way to running your own. The only other things you'll find in here are this test script. This is a hefty chunk. It's what the container that we're building runs when you run the build script. This is the entry point. By default, it sets up a small bash array to run a series of what would we call these? Smoke checks, smoke tests, integration tests, maybe unit tests, but they don't really fit into that paradigm very well. Functional tests. I'd say smoke testing. It tests the container to make sure each of the installed CLIs works. The Docker files over here, I'm not really going to go into it too much. It's just pulling in the CLI. It sets some variables. These are build args that it sets in the beginning, sets your work directory. I think it's pretty self-explanatory using latest because this is just for testing, so who cares? Pulls in the CLI and updates the container and sets that script to the entry point. So if you want to run it locally like I am here, override the entry point is my recommendation. So we set up a command array here. Some of this will run even. I could have made this script more robust, but again, it's for testing, so bear with me. Here's the IAM role we created. Here's a series of CLI commands to create and attach. These are managed Amazon policies. These are not the usual custom policies you might be creating yourself. These are Amazon managed. Another caveat, I'm not really fond of these usually because they can change these permissions out from underneath you out of nowhere. But again, customization versus operational overhead, it's nice to use managed options when you can because I don't have to maintain these policies either. So we create, this is a node role that will allow new nodes, as Carpenter brings up new nodes, this will be assigned to them, and it will allow them to join the cluster via OIDC. I think under the hood is how Amazon does it that way. There are node certificates involved, but I think under the hood it does an OIDC. It creates a job for it. Don't quote me on that one. This runs the EKS control CLI, which brings up the cluster, just refers back to that cluster config. Then we get the role itself and create some access entries. I can do a tutorial. I'm not going to cover access entries. It's an alternative to the AWS auth configuration map that normally maps Kubernetes RBAC to IAM, various IAM entities, for specifically in the direction of AWS reaching into Kubernetes API. To go the other way, you use things like URSA or mount OIDC tokens and such things. There are other. We used KIM back in the day. I think URSA is a better option in general. And this is just to allow the nodes to join the cluster. It then updates the kube config. This is just a command that pulls down the latest kube config for your cluster and sets the context to it. This then quickly applies the node class and node pool because no nodes will come up until these are applied because Carpenter has nothing to work with. And then it applies this good old sample app. This is a common one. It loads several front-end deployment, a cache layer in between via Redis, and the guestbook all in one thing. Here is just some back-end services that talk to Redis and so on. And we'll show this running in just a sec, just to show that everything's good. And that's the extent of it for the most part. The build script you do run, this you just run from here, run from a terminal. It will build the container and then just run it in a removal, it'll remove itself when it's done. And it should build out the whole cluster for you. Now this default config file, I'm not going to bring it up here because it currently has configuration in it, but you just stick your access key and secret access key in there. There are more robust ways to identify yourself for this sort of activity. You probably will not be doing it from a workstation, or you shouldn't be. Shame on you. For testing is fine, of course. So this would normally be handled probably by, again, an OIDC or just traditional IAM, STS assumed. It's STS for both. Pipeline role that would, you'd have some service like code pipeline or maybe Jenkins if you're old school, or GitLab CI/CD or GitHub Actions or Circle or anything you're using as a CI/CD platform would handle it from here. So this is just a cheap, easy way to give get creds on your own test accounts and test with it. Don't do this in production. And we covered the Docker file. So I think that's about it for that. I'm going to go over the objects that were created here, and then I'll end by showing how auto mode is a little different than what you're used to. And then we'll maybe view the app real quick just to show that it's working. And we'll call it a day. I'm just glad I finally got this video out. Oh boy, a social media personality? I am not. So this is the node role we created in IAM. The whole purpose behind this is also what that trust policy JSON document there is for. And if you look here, these are the minimal policies at the moment, at least as of this video, that were needed for a node to join an EKS cluster, to pull down containers, and to run the CNI plugins and create ENIs and that sort of thing. Without this, the nodes won't join or won't have the ability to create, again, ENIs or anything like that for networking purposes. So this is needed. I Don't have anything else to say there. You saw the details before. EKS control creates a cloud formation stack. If you don't like cloud formation, I understand completely. It's not my favorite IAC tool either, but it is what EKS control naturally creates. So if you're using EKS control, you kind of are dealing with this. I don't think it's a terrible trade-off myself, but you have many other options. You can do it with Terraform, you can do it with Ansible, do it via Pulumi, use Python for it. There's Bodo. You could technically just do this in raw Bodo. So here's what you get. The advantage here is when you're done, you can just delete this stack and it'll get rid of the cluster. If you look here at the cluster, we have a typical 1.30 cluster. You can see our resources. We'll show those from the command line too, but you can see we have resources created. And the compute is these two T2 medium instances based on those node class and node pool configurations that we had set up before. Yeah, that's about it for here. You can see the rest of this is just detail. I'd be happy to go into anything that looks into. I can go more into EKS tutorials if they're more low level or more detail there. If desired, please let me know. Spent many years as a Kubernetes administrator, much of it in EKS. I'm going to go ahead and kill that for now, and I don't think we need this page anymore. I'm going to delete this when we're done. But before then, let's take one quick look at what is interesting about auto mode. So as you can see here, I have my front end pods, the Redis cache, write and read replicas, and metrics server is installed as an add-on here. You can still use add-ons. You can still install anything else. I could have installed an ingress or gateway. You could install Istio on top of it. It will support all workloads. But you'll notice you're not seeing any of the CNI plugin pods, right? You're not seeing core DNS. You're not seeing kubeproxy. You're not seeing the secret to life that Kubernetes reveals to you every time I've just been staring at these screens too long. What you see here is, I don't know if they're virtualizing clusters like something vCluster would do, or Kubernetes in Kubernetes kind of thing, or if they're doing a admin user kind of plane where we get to see we get to see the data plane, so to speak. We get to see the worker node side of it, and all the other components are running remotely. The advantage of this is, so to cover auto mode where it fits, the advantage to this is that all of your components, core DNS, the CNI plug, the network pods, whatever they may be, usually CNI plugins, sometimes with Calico or Cilium, the kubeproxy instances, the like load balancer controllers or things that are gateway controllers, those sort of things, all the pieces that you run, which used to be add-ons that were pretty well managed, but you had to still update them yourself. You still had to work with them yourself. Now, you don't see any of them. They're being scaled and managed for you in the background. This is a wonderful release of operational overhead that you get drawn into just updates upon updates upon updates. Admins out there, tell me if I'm wrong. 95% of the job sometimes is making sure updates are stable. And in this case, it's being done for you. Much like serverless technology in general, much like managed technology in general, you don't have as much control over. There are certain, as you notice, you can still apply various Kubernetes objects, including CRDs, to configure these components, like me configuring Carpenter. Carpenter is not running on my worker nodes, but it is still, I have a control plane in the background that's still, managing the nodes for me based on my own configure. I don't have to go with the defaults, right? I still have my own, some customizability here. I can still install network policies, for example, even though I don't have the CNI plugins available to me directly. So I would say that if you've already looked at the fully managed route, by that I mean quote unquote serverless technology, such as Fargate is a Kubernetes option. It can target Kubernetes clusters. And you may find that either the performance or the scaling, you may find failure modes even are not what are not working for you. Usually then one kind of goes back to managing more and more of the infrastructure until you get the control you want. Maybe if you're a big telco, you are running your own hard networks everywhere, and you're running your own hardware because you need that level of control to run to be an ISP or to be a telecom. On the high end of it, if you're running a web application, you might stick your app on something like Heroku or Vercel, or use something like DigitalOcean. Or I mean, we can go through different levels, layers of abstraction here, depending on what you're trying to do. I think auto mode fits right beside fully managed technologies. There's still plenty of stuff for you to do here if you need to tune things, but if you need tight control over the various system components, obviously it's not here. That's always the trade-off. More customizability, more work. That's cloud in a nutshell. So I think the best bet is always to do your research, POC a completely managed environment for whatever pieces you can that fit. If their performance, or if their reaction under pressure, or if deployment, or if any of these things become a problem because of the nature of the beast, wind yourself slowly back. So in this case, the progression will probably be from Fargate to POCing with auto mode to EKS with managed node groups, AWS managed node groups running add-ons, all the way down to self-managed nodes that you customize and run yourself without using the add-on mechanism. You have fully customized installs of every service you want, including the CNI plugins and Core DNS and so on. And I really think you shouldn't put yourself in that boat until you have to. But if you have to, don't fight it. It's just comes with the job. I'm going to do one more thing here. I'm going to get the service for the front end, and I am going to proxy. I'm going to port forward, and it's proxying the service front end. Just to show this working, I'm going to pipe it over to 80. Now, if I go back here, go to localhost. Oh, that's embarrassing. Hold on. What did I do wrong here? Got some live troubleshooting here. This is what happens when you don't have any editing skills. Oh, I know why. Hold on. Excuse me, folks. This is some live troubleshooting, but I will go ahead and I will eat it. I was doing that from inside a container, and I had not a container that was attached to my host network. I'm just going to leave this in because I think it's an interesting point about Docker. I'm going to leave my mistake in here. The container was isolated in its own Docker network, was not attached to my host networking, so it couldn't reach my host machine. However, if I do this again, this should work. Apologies for such. What did I do now? Oh, wait. I skipped a step. So this is the update kubeconfig command. I'm on top of this. This will pull down a kubeconfig for me once I. Oh, I know why. Excuse me. What I'm actually going to do here, you know what? I'm going to keep fixing this over and over again, which is going to look silly eventually. I'm already keeping in my mistake, and I'm going to keep this in on purpose. A, because I have no real editing skills, but B, I think this is interesting. I was trying to get around it, but I realized the best way, if you're going to run this yourself and you want to do what I'm doing, the test here, I ran it without this net host. It was running in its own network. So I'm going to go ahead and run this here. I'm going to override the entry point to bash. And now I'm going to, once again, whoops, not spelled correctly here. Okay, I really am doing well here. Oh, well, it would help if I once again ran the update cube config man. You have to run this each time you start this up unless you include it as part of the run. Okay, now we have the guest book app, and there is more you're supposed to do with this. So if I type a message in and submit it, I don't really see much going on here because with these samples apps, there's always a little more configuration to go. But as you can see, everything is more or less okay. Pardon all the troubleshooting here, but I'm going to leave this in because I do think it's an interesting little bit. And I've found that most other IT folk on social media, although they have much nicer videos than I do right now, tend to leave this sort of stuff in as a learning experience. So I'm just going to go with that. So that's going to be the end of this video. Apologies, you're about to see my horrible OBS nightmare again. But if there are any questions, any comments, please reach out. And if more tutorials like this would be fun, or anything else you want me to cover, please let me know. Otherwise, good morning, good afternoon, and good night to everyone out on the intertubes. And I'll talk to y'all later. Here's the nightmare again. Look at this. You can see my tiny point, like the tiny mouse pointer, all way, way off in the distance. If I look hard enough, I swear I can see myself looking back. Yeah, all right. Time to end this video for sure. You all have a good one.